Hello, everybody. My name is John Richter, and today I'll be going over the parameters and the anatomy of a gate. Most people use gates in the recording process to remove bleed or leakage, and that's primarily what it's used for, or it could also be used for other effects such as a ducking effect or triggering of some sort. But today I will be going over the parameters of the gate. So anyways, right down here, start from left to right. So what we're gonna do is this. We have the gate, we have the ducker. As we know, the gate will remove ambience and bleed from another instrument, and it allows us to isolate one specific sound that we choose to. The ducker, on the other hand, is almost like it's literally like a side chain. You know, we have side chain up here, but basically what it'll do is it will duck out of the way as another instrument is playing. So, for example, kick a bass. Perfect example, you have your kick going boom, 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 your bass is going boom. What it'll do is as the bass goes, it'll duck the bass, the kick will pop through, bass will come up, and it continues going. So basically that's all it does. The bass comes, whoop, here comes kick. Pop, whoop, boom. That's literally what it does. Well, that's the ducker. And obviously, you know, depends on how much you want compared to how little you want, etc., etc. So that's something you can definitely experiment with and get the correct parameters for whatever project you are working on. Below this, go back to gate, we have the threshold. The threshold is the set threshold level. And this is a signal that falls below the threshold and is reduced in level. That's what the threshold is for the gate. Next to this, we have the reduction or, the ducker knob. And this is to set the amount of signal reduction, how much is reduced. And obviously for the ducker, it's how much pumping, if you will, how much of that ducking effect you want applied. So back to gate. Below this, we have the hysteresis slider. Now this slider will set the difference in decibels between the threshold level that will open and close the gate. Open and close the gate. So basically, in a sense, this parameter right here, it prevents the gate from rapidly opening and closing when the input signal level is close to the threshold level. So whatever level this is at, it will determine that in decibels. It's very nifty. So I typically have that a good portion up so that way there's no um, rapidly interruptions from the gate. Okay. Over here, we have the open, we have the close indicators. This shows the current state of the gate, if it's open or if it's closed. And you can see that as, you use the gate, which is, I actually like that. It gives a very visual representation of when it opens, when it closes. Below that, we have our attack knob. This knob will set the time it takes to fully open the gate after signal exceeds the threshold. So once it gets past here, this will take control of how opening the gate will be. Next to that, we have the hold parameter. And as you, like I didn't say this before, but they're all in milliseconds, as you can see, millisecond, millisecond, millisecond. And the hold knob will set the time the gate remains open after the signal falls below the threshold. Right next to that, we have the release. And the release will set the time it takes to reach the maximum attenuation or cutoff after the signal falls below the threshold. Basically, in a sense, I'm sure you can get a gist of the attack, how quickly it comes in, hold, how long it holds, that signal holds out before it drops, and the release, obviously, like almost like a release tail, the decay. How long will it stay actively open before closing? Well, those are those knobs. Below these parameters, we have the Lookahead slider, and this controls how far ahead the noise gate analyzes the incoming signal, allowing the effect to respond either more quickly or slowly to your peak levels. I tend to have this at a higher setting so that it responds faster. So hysteresis and a look ahead, they have a slightly similar outcome in preventing things from happening too quickly. But like I said before, mess around, see what fits your parameters. Over here, we have the characteristics pop-up menu, which you can choose between a bandpass and a band reject filter. Okay, cool. Those are the filter types that are available. Next up, we have the monitor button, and the monitor button is turned on here, this sidechain signal. So if you have this sidechain to an audio signal, an instrument, or an input for that matter, then you will be able to hear it via sidechain with this button, which including the effect of the high pass and low pass cut filters, if enabled. Below that, we have our high cut and low cut filters. Okay, and these are activated by this button right here. Without this button, they are not activated. So once you activate that, you have your high cut and low cut filters activated. And as many of you know, as producers and engineers, if you set the upper cutoff frequency from the sidechain signal, you have a higher to lower setting of hertz. And with the low cut, you can set the lower cutoff frequency for the sidechain signal. So higher you go, the lower you go. So just that also depends on taste. But those are the basic parameters and the anatomy of a gate. So I'm hoping you enjoyed this video. I'm hoping that you took something away from it in some form. And if you have any more questions regarding the anatomy or parameters of a gate, feel free to comment below or reach out with any other questions or concerns you may have. All right, well, thanks again for watching. Enjoy your day.